In this question, we've been asked to find the 10th term of the arithmetic sequence -4, -1, 2, 5, etc. So if we think of that, our nth term can be found by our first term plus n minus 1, so the number of the previous term times d, which is our common sequence. Okay, well, our common difference, sorry. So therefore, in this case, our a value, so our initial term, is -4. And our d value is the difference between each term. So if you look at this, each term, it's increased by +3. Oops. So our d is 3. So the common difference between each term is 3. So if we substitute those in, we get a general rule for this sequence. So our nth term can be found by -4 plus n minus 1 times d. N minus 1 times 3, because we substitute 3 in for our d, our common term. So now to find our 10th term, so our 10th term can be found by -4 plus 10 minus 1 is 9 times 3. So -4 plus 27 gives us a value of 23. So therefore we can say our 10th term equals 23. In this case, we've been given an nth term that's 41. Okay, it's in the same sequence, but now we want to find out which number term it is in the sequence. So if we still know that our sequence is our nth term can be found by a, which we knew is -4, our first term, plus n minus 1 times 3. So we know that our nth term, in this case, is going to be 41. So we can substitute 41 in for our nth term. And so we've got 41 equals -4 plus n minus 1 times 3. So now we can just work backwards. Okay? So take out -4 over the other side. So we've got 41 plus 4, which gives us 45 equals 3 times n minus 1. Divide by our 3, so 45 divided by 3 gives us 15 equals n minus 1. And so take our 1 across, therefore 16 equals n. Therefore, we can say that 41 is the 16th term in the sequence. In this situation, we've been told that the 12th term of an arithmetic sequence is 9 and the 25th term is 100, and we need to find a and d and then find what the 8th term is. So if we know that our arithmetic sequence is our nth term can be found by our initial term a plus n minus 1 times d. So if we know that when our 12th term is 9 and we know that our 25th term is 100. So I can sort of say that, looking at our 25th term first, so I can say that when our 25th term is 100, okay, then I've got a plus, our term is 25, so 25 minus 1, so our n value is 25, n minus 1 is 24 times d. Then I'll call that equation 1. Then if I look at this one here, I can say my 12th term is 9. So 9 is the value of my term, and that equals my first term plus n minus 1, so n is 12, 12 minus 1 is 11, times d. So I can call that equation 2. So now I still need to find what A and D are. So if I look at this, and if I subtract my equation 2 from equation 1, 100 minus 9 is 91. A minus A cancels out, so that's 0. Okay. And then 24 minus 11 is 13. Lots of D. So 24 lots of D minus 11 lots of D is 13 lots of D. So now I've got this, 91 equals, 13D. So then I can regroup. 91 divided by 13 equals D. So therefore D equals 7. Now that we've found our D value, we can substitute it into either equation 1 or 2 to find out what our A value is. So if I know that one equation that is 9 equals A plus 11 times 7. So because we found out our D value was 7. So therefore 9 minus 77 equals A. So therefore negative 68 equals A. So this gives me my rule for my arithmetic sequence that my nth term, so Tn, is going to equal negative 68 plus my D value is 7 times n minus 1, or n minus 1 times 7. The question then asks me, what is the 8th term? So I can now substitute in. T to the 8 equals negative 68 plus 7 times n minus 1. So n is 8, so 8 minus 1 is 7, which gives me negative 68 plus 49. So my nth term is going to be negative 19. Oh, sorry, my nth term, my 8th term.